Let's think about this. If you go into the internet and you Google airfoils or aircraft wing profiles or terms like this, you find hundreds and hundreds of drawings. You find airfoils for all kinds of purposes. You find all the funny curvature, and in fact they all have a reason and they all have their purpose on their own. At this point I'm interested in this very simple, very general purpose airfoil, and I asked myself, is it symmetric or not? Now, symmetry can be looked at in various ways. You can look at symmetry around various axes. In the case of an airfoil, we look at the symmetry in height over the cross section. So, looking at this right now, this here is the cross section. So, following this line describes the cross section, and I want to see if I can cut this into two halves which are identical. So I go very conventional there and look at the most forward point of this airfoil, which is probably here, and I look at the most rearward point of this airfoil, so the longest extension of this one, and I draw a straight line between these 2 points, which would be about this. Now we remember, we call this one the chord line. Yes, this is chord. And the length from here to here is my chord length. And this would be my symmetry line. So if I could cut the profile into two halves which are identical, then that would be the a symmetrical airfoil. Now in this case it's obvious it's not symmetrical, even if I didn't draw it very accurately, it's definitely not symmetrical. The upper part is more rounded than the lower part. Now I can look into this a bit closer, and I draw another line here which goes vertically through the chord line and through the maximum thickness of this airfoil. So here we have a 90 degrees angle, and this in fact defines my thickness. Now I can go and can draw this line on equal distances, like this. And at every point I halve these lines. So I look for the same distance from the bottom to the center point and the top of the profile to the center point. So I need to agar a bit, but it turns about to look like this. And obviously here's the center point. So if I combine these points with a single line, I have something new. Yes, this is the camber line. And the distance here from the chord line to the camber line is called my camber. If the camber line is straight and identical with my chord line, I also have an indication for a symmetric airfoil. If it is not, the airfoil is cambered. Any cambered airfoil is asymmetric. Well, that's the way it is.